Oh, hi everyone. I am going to plan to perform a asymmetric Young's experiment or asymmetric double slit experiment. Traditionally, the Young's experiment or double slit experiment are symmetric, which can be seen easily if anyone is familiar with the mathematical or geometrical explanation of a double slit experiment, which is often done by drawing a straight line with two gaps as such. This represents a slit. This represents another slit. And this is a straight line. Represent the wall blocking either water wave or light or electron, whatever you are performing a Young's experiment with. And this is a straight line. And the rule of this line represents the wall or some kind of a board blocking the waves. Their role in this entire theater is nothing but a blocker. However, if you were a water wave and these blockers are solid, but if you were a photon or an electron, these walls are no longer solid. For example, if you were an electron, the very end point or the edge of the slit is an atom, and you can see it as an electron. When you pass through this slit, if you were going through right in the middle of it, you may get a symmetrical interaction between this atom and this atom, and you may not, because this atom over here and this atom over here may not synchronize their activities, their electrons' movements. However, if you were somewhat off the center, and you're going to interact more with either side atoms. So these walls or these lines are actually active actors in this double slit experiment theater. Therefore, the purpose of me performing a asymmetric double slit experiment is to show the role of these atoms in a double slit experiment, which have been neglected for more than 200 years. However, because the double slit experiment got three actors in this wall, and a asymmetric situation is difficult to set up. What I have done I use different material to represent a different atom or represent a different electromagnetic influence in this slit. For example, I've used copper, aluminum, and iron. I mean, it's actually steel. A stainless steel. That's what I bought to perform a double slit experiment. For the middle part, only thing I can buy is the copper wire. So when this is copper, then other side can only be chosen the iron and aluminum. So what I have done is aluminum, iron, and a copper wire in the middle. However, the result isn't very. It's kind of complicated to analyze because you got three actors, kind of like the mathematical problem, two-body problem, three-body problem. Three-body becomes way too more complicated. I also tried to put a fishing line in the middle, but that is a insulator, so it kind of like defeats the electrical purpose. And I also used my hair put in the middle. The result is kind of interesting, but it's not up to my desire for a asymmetric result. So eventually I did my plan become a just do the single slit experiment and use two different materials to perform a single slit experiment. Say, for example, the upper is copper and the lower is iron. Put a copper on top or on one side, put iron on the other side to create a gap. Use that gap as the slit. Eventually, the plan is using different kind of a foil. Say, for example, this is a stainless steel. This is a copper. And this is aluminum. And this is brass. However, eventually I did not use brass because the result is not not very distinguishable. And the plan, even try different methods. The plan was eventually become using the washers from Home Depot because they are flat, so they will help me hold the foil somewhat aligned. And I used the double-sided tape to glue or to hold the metal pieces I cut off. Then I use another washer with double-sided tape to push them together. The final product is this. Two washers hold two pieces of metal in the middle, and they are not touching, so that you have a gap, and that is my single slit. As you can see, this is the copper, and this is iron. I mean, stainless steel, actually. And I also used the nylon washer, and this is copper, and this is stainless steel. I'm not sure whether you can see this is a somewhat transparent, probably not transparent enough to see the shape in between. Okay, back to the double slit experiment. The double slit experiment, because they are often done with the same material. I mean, that's also why I call it this, they are all symmetric. They are using the same material. And all this, there are no differences whatsoever. Geometrically, they are aligned. There's one line with two gaps. And which represent their, as a mathematical model, represents their experiment, which is relatively accurate. However, when I try to use two different materials, the alignment become a problem. For example, it could become something like this. And a copper could be a little bit in the front, and iron could be a little bit behind. And asymmetry, there are two factors of my asymmetric experiment. One is geometric asymmetry. One is the material asymmetry. Namely, the very end atom, here's iron, and here's copper. And these two are not symmetric. So the result could be caused either by the electromagnetic situation, asymmetric electromagnetic environment, or by the geometric asymmetry. However, geometric asymmetry is relatively easy to overcome, because I will take two pictures. See, the light, the laser I'm going to use come from this direction. Laser come from this direction. The upper slit is in the front, lower edge of the upper slit is in the front, the edge of a lower slit is in the back. If the eventual result, asymmetric result, is solely caused by the geometric asymmetry, I will take another picture. Namely, I will flip the situation 180 degrees. Iron become in the front, copper become in the back. But copper now is at the bottom, upper is on the top. If asymmetry over here is caused by geometric asymmetry, in this case, the geometric asymmetry still remains the same. Therefore, the picture should stay the same. Otherwise, the difference of the material is the main factor, or at least is a factor causing the asymmetric result. The asymmetry of the eventual result is caused by the difference between copper and iron. The actual performance would be, first, take a picture with the laser or video even, with copper on the right, iron on the left. Then flip them over. Iron become left and copper become right. And in this case, the geometric situation remained the same. If the final picture or the characteristics or the asymmetry remains the same, then that asymmetry is caused by my misalignment, my poor handiwork, a geometrical asymmetry. However, if the result flipped, the asymmetry would be caused by the difference of copper and steel, because that asymmetry followed the copper and steel. I hope I have made it clear enough. You see, this is like when you flip, that is like turning this 180 degrees. Geometry remains the same. The material switch sides. If the result remains the same, then that result is caused by geometry. If the result also flipped, then that result is caused by the difference or the asymmetry of the material, the difference of the iron and copper. Of course, I also used aluminum. In the next tape, I'll show you the full radio. I'll record them all for science. Alrighty, that's it. That's the plan. The result is actually overwhelming, and of course, you know, all I need is an exception, namely, the wall is an actor in the double slit experiment, especially the edge of the slit, or the most outside atoms of this edge of the slit. It plays an important part in a double slit experiment. With regular light, the energy is too low. It doesn't show. However, with something higher energy, first I thought, you know, you probably have to go to electron, and I will have to invest in an electron gun and so bunch of other things. But I tried with a little bit more powerful laser, and I'm happily surprised by the power of a laser. And laser is good enough to show what I wanted. Alrighty, so this is the plan. Next will be the performance of an experiment. Alrighty, see you guys in the next video. Bye.